Very good. Okay. We'll wait for another 2-3 minutes, then we'll start. How is the weather in Cornell?
I'm in North Carolina. The weather is rainy but cold, a little cold.
Cold, okay.
Yeah.
We are reeling under heat.
Oh, I can imagine. Yeah. April is like
It's 38 to 40. It is in the range of 38 to 40.
Wow.
And particularly in North, it is still higher.
Yeah, I can imagine.
So, IMD has warned that the heat waves will be, intense, in the month of May.
Oh, wow.
Yeah, we are little lucky because of the sea is there in Chennai,
Correct.
So sea breeze sets in, after lunch. From
Right.
2 onwards, you start getting the breeze to some extent. But anyhow, it is a hot breeze. It is not.
That is true. Yeah.
I think we can, another 1 minute, 6:05 will start.
Okay. Sounds good.
Yes, recording. Recording. Dr. Nambi will do the welcome and set the stage.
Yes, sir.
Then I will do the introduction of speaker. I will do. Then you can take over.
Okay, thank you.
So, Dr. Nambi, can we start?
Yes, sir.
Yes, sir. Please.
Yes. Good evening, one and all. Joined here. Around 480 participants today. They are interested in joining this. I welcome you all for this wonderful event. In fact, this is an opt event. At this juncture, we'll be talking about machine learning, artificial intelligence, and optimization. And we have with us opt person, Dr. Radhika, and she has very rich exposure. I haven't imagined that. I taught many times the SAS course to my postgraduate MSc students.
Okay.
I never thought that I'll share a meeting with Vice President of SAS. So it's a great opportunity for me to welcome Dr. Radhika for this wonderful event. And of course, for this kind of events, Dr. Mohan is quite familiar and he has taken a lot of initiatives. He started this initiative just a month back and he keep on sending messages and he'll be doing all these events for many times throughout the year. I welcome Dr. H.R. Mohan for such a wonderful organizing such a wonderful event. And I welcome Dr. Aguila for organizing this event. First 1 week, she keep on sending messages and she's transforming this event for a fruitful manner. And Dr. Sakthivel, I think he's out of station. He said he'll be joining to this event. We expect Sakthivel to join us. On behalf of ORSI, and CSI Chennai chapter. I welcome wholeheartedly everyone for this event. Definitely, this event will be a major boom. Those who are working in artificial intelligence, optimization, and machine learning. In fact, personally, I like this topic. I'm expecting more from the speaker. I thank the speaker for accepting for such an event. Thank you all. Once again, I welcome you all for this event. Thank you, sir. Thank
Thank you, Dr. Nambi, for your welcome note. Once again, on behalf of the IEEE Computer Society, ACM Chennai, and CSI Chennai, and ORSI. It's another institution which I can permitted to call it is a mother of computer science.
Thank
Many
you.
of the techniques are drawn from ORSI. I mean, that's what I was talking to Dr. Radhika. I was making a mention that, computer science, because it is applying the techniques of ORSI, war, so it has become much more popular than war itself. So normally it happens, the sun grows much faster and gets more visibility. In fact, in many of the organizations, it happens. Like, for example, HDFC was the parent company. HDFC Bank was a subsequent this one. Now it is HDFC Bank has grown much bigger than HDFC itself, and the government has approved the merger of HDFC with HDFC Bank. so that way, that ORSA has been always keeping the background, but silently giving all the techniques for computer science and things like that. And it is a very nice evening that we are able to get Dr. Radhika for our webinar. Particularly, is combining all the major developments happening in the field of computer science, that is, machine learning, artificial intelligence, and optimization. So everything is, ultimately we are interested in optimizing so that our maximizing profit or reduction of cost. The optimization, always look at it in terms of getting maximum benefit from the processes and so on. So this wonderful lecture we are really awaiting. And I have great pleasure in introducing Dr. Radhika, who is an advanced analytics professional, active in the area of operational research, AI, and machine learning. She recently superannuated after 35 years of leading various areas in analytics, R&D, and SAS Institute. In fact, during our days, we have been using the SAS package and SPSS, SAS, there are statistical packages, competing packages. And of course, now with the R techniques, and there are few more packages have come. And for the last 10 years, during her career, Dr. Kulkarni was the Vice President of Advanced Analytics R&D, overseeing software development in many analytics areas, including statistics, operational research, econometrics, forecasting, and data mining. Dr. Kulkarni has been an active member in the Institute for Operational Research and the Management Sciences. Incidentally, I also happen to be a member of this Inform, and that's how I came to know about Dr. Kulkarni, and and approached her for the possibility of giving a webinar series in our program. She was readily willing to give this. Thanks, madam, for your ready accepting to our request. Throughout her career, and also the recipient of the Women in Operation Research and Management Sciences Award, she was recognized as an Informed Fellow during the year 2014 and served as the president during the year 2022. Very recently, she is now, I think she is a immediate past president of the Inform. Dr. Kulkarni serves in the Advisory Council of School of ORI at Cornell University. I think this is a war and industrial engineering, I suppose. And the Master Science and Analytics Advisory Board in Georgia Tech, and Advisory Board in the Business Analytics Program at Sabancı University of Turkey. Dr. Radhika Kulkarni has a bachelor in mathematics from Presidency Madras. In fact, we are very happy to, during the interaction, come to know that she had stayed in Ashok Nagar. So it's very close to our things hailing from Chennai. So we are very proud that we are getting back. I think we have rekindled our memories of Chennai. So and also had a master's in mathematics from IIT Delhi and PhD in the year 1981 in operational research from Cornell University. So with a rich background and experience, and definitely this presentation is going to be extremely interesting. Anyhow, we had a preview during the dry run, so we have really seen what do you call it? We have seen the teaser content, which is excellent, and I am sure all the participants will enjoy the proceedings of today's webinar. And I leave the floor to Dr. Kulkarni.
Thank you very much, Dr. Mohan and Dr. Nambi, for the warm welcome as well as the introduction. I hope I'm worthy of all that. So let me bring up my presentation and so that I can get started. So I'd like to start out by thanking IEEE Chennai, ACM Chennai, CSI, and ORSI Chennai for inviting me to give this talk. And as Dr. Mohan just said, yes, it is nice to be interacting with Chennai folks. That's my hometown. So I'm very glad to be here. And also, you mentioned that OR is the mother of computing. And thank you for saying that. And I know as Chennai residents, Tamilians, most people know the saying that you're always proud when your son succeeds better than you, right? So with that prelude, I'd like to start. What I'm going to talk today is just a brief overview of some of the areas of innovation and research that we worked on while I was at SAS, and my team at SAS continues to work on these problems. And I have seen these problems driving innovation in many different industries throughout my career. So I'd like to share some of that and give you some of the reasons as to what is driving all this innovation. So what are the business problems that are driving this? And something that I have always believed in very, very strongly is that it is very important for all the analytical disciplines to interact with each other. So I was a big proponent of interdisciplinary research, which I promoted at SAS, and I continue to do that in my discussions with universities and at Informs as well. And finally, I'll end with a few, ideas or barriers, talk about some of the barriers for implementation and success. So as I go along, I'll explain some of the terms that I'll use so that we are all on the same page. So, and many of you might have seen a similar chart like this, and this was something that we put together many, many years ago, which talked about all the different types of problems that the world faces and how do you solve them. Sometimes it's just like looking in the rearview mirror and seeing what happened. Some other times it's where you look at what has been happening and try to predict what is going to happen next. And given all of this information and a lot of this data, what we want to do is to figure out what is the best that can happen so that we can maximize our profit or minimize our cost or just in general optimize. So those are all the different ways in which many businesses or almost all businesses address problems. So at SAS, we have used the term advanced analytics, and I think that's used more commonly as well. And I'd like to just briefly say what that means. It is the use of quantitative techniques like statistics, data mining, forecasting, etc., to guide and support critical business decisions based on customer and operational data. And they're often classified by the nature of the decision support. So like I said, what happened in the past past, or looking at data and getting an idea of what is happening. That's typically called descriptive analytics. And if you want to look at the trends that have been happening, or look at a group of people and say, this group is behaving like this, how will another group behave? Those are known as predictive analytics. And prescriptive is where you're prescribing the best action. So optimization and OR types of techniques pretty much come into play at that. So it has been commonly described in these three different buckets: descriptive, predictive, and prescriptive. And I know there are a lot of people in the audience who are very familiar with OR, but I just want to just make a brief statement here as to what is operations research. When I talk about operations research, it is the science of making data-driven decisions using mathematical modeling. And it is a science in the following way. There is a framework that is used to make decisions. For instance, if you take this example, many of us who've been on airline flights get bumped because we go to the airport and see that the airline, that particular flight is overbooked, and they say, oh, we need to bump a few people, we'll give you some money, etc., for taking a later flight. And why is this? Because airlines want to make sure that their plane is full and no seat is empty when it flies. In other words, the airlines wants to maximize the revenue. And the decisions that the airlines has is, how many tickets do I sell? So if they sell exactly the same number of tickets as they have seats on the plane, it is possible that some people may not show up. So then they're flying with an empty seat, with some empty seats. So they typically overbook, and so that they can account for the no-shows. But sometimes they have overbooked too much, so they have to resort to bumping some people. So then, so the decisions that the airlines makes are for a given flight on a given day at a given time. How many tickets should I sell? How much do I overbook? And the constraint, of course, is the capacity of the plane. So any OR problem is typically framed in this fashion. You have a goal that you want to achieve, either maximize revenue or minimize cost. There are decisions that you want to make that are at your disposal to make those decisions. And there are constraints. In this case, the capacity of the plane. Other cases, it's the budget, is the capacity of the room, the stadium, or the space that is available for loading your merchandise, etc. So those are all the three factors that are needed for an OR problem: a goal, a decision, and and constraints. And many times, if you've been brought up in an OR mindset, you look at almost every problem like this. So that is something that I tend to do all the time. And of course, the data that goes into making these decisions are what are all the previous flights. So the airlines is not making these decisions blindly. It's not just picking a number out of the hat. It looks at all the flights that have happened in the previous days for that particular date and day of the week and time of day. And based on that, they say this is what the demand is going to be. So they'll forecast demand. And then based on that, they will decide, okay, now this is how much we're going to overbook. So that is how you frame any OR problem. Right. So the formulation of the operations research problems is what I just described. Along with all of this, as we have seen over the past decades, big data is something that we hear about all the time. And the complexities of the big data world has increased enormously. So you can see the different sources from which all these data are coming at you. It could be from on your phone. You get all these messages, the WhatsApp or messages and emails, etc., text messages. There are lots of sensors in any of the planes that you fly or cars. Many of the cars have so many sensors that are put there to detect whether something is going wrong. So sensor data, video data where you're monitoring who is coming and going at a bank or at the airport, what's happening. So, or Twitter, Facebook, all of these have text data that are constantly coming at you. So the number of data points that are coming, the sources of data continue to grow exponentially as we continue to add more and more of these sources of data. So with all these different sources of data, there are different types of business questions that need to be answered. For instance, they could be a question you want to know as to, I'm going to have a marketing campaign, and who is the person who's going to respond? Who are the people that will respond most positively to that campaign? So in order to make that decision, you need to have data about the different demographics for each person. You have all the different attributes. Does he, is he on Facebook? Does he blog a lot? Or does he have a lot of friends? Or what is his age or her disposition, and what is their income? These are all the demographic information about each person. So based on
that Radhika, at the bottom, can you just say one message line is coming? Can you make it hide?
Yeah. Thank you. Yeah, I was wondering how to make that go away. Okay, let me see. Okay, did I just lose this? There you are.
Yeah.
Can you
Okay,
see the
fine.
screen now?
Yes. Fine.
Okay, thank you. Okay, so thanks. I was just wondering what I should do about that. Thanks, Mohan. So who will respond to the campaign? And then, if you're looking at past demand, like I said, in the airline problem, you want to see, based on that, you want to see what the future demand will look like. So for that, you need time series data, timestamp data. So for the different times of day, different days of the week, what was the demand like? And based on all of this, there could be, you're looking at these changing landscape over time for a whole set of people. And this was something that we've seen, all of us, in the past 2-3 years, as COVID data continues to come in from all kinds of places. We've seen, how the COVID virus has spread, and where has the infection increased, etc., and what kind of regulations to put in place. And so there you're looking at the entire population over time to see how the infection rates have been changing, etc. Then you're looking at some text data, and you can just see the different types of data and in what form they get collected, and what kind of analysis you can do, what kind of results can you get, or impact can you get, or value can you get from that data. So the point I want to make is each data source, depending on what you're trying to do, requires a different modeling technique from different analytics disciplines to understand and get value from it. So when you're trying to predict who is going to respond to a campaign, you need predictive analytics like data mining techniques, machine learning techniques. If you're trying to predict future demand, you need some forecasting methods. If you're looking at or time series methods, if you're looking at text data, you need some text analytics. So for every different type of data source, you need different analytical techniques to solve them. And often different researchers go in depth into any one of these. So while I was at SAS heading up the analytics R&D division, there were different teams in my division. Each of them had specialization in some of these different techniques. So the question is, how do you bring them all together so that they can augment each other's strengths and learn from each other, and how one discipline can be used in another to get better results or create better algorithms. So that was the focus of the direction that I was trying to lead my team at. So essentially, you have data, you want to apply a bunch of analytical techniques to get value from the data. And what has changed is the data keeps growing and growing and growing. So the opportunities for insight and innovation naturally come from augmenting the legacy data sources with auxiliary data. Traditionally, if you were looking at some statistical analysis, you might have looked at analyzing the crop yield, or how much can you, what is the result if you give these fertilizers to these crops. That's where a lot of the statistical analysis started, with analyzing crop data, farm data. So looking at those are the data sources that typically people have looked at. But now, as more and more data sources are available to us, we can put them together and use some auxiliary information to get better in value from your entire set of data. For instance, you could add some social media and behavioral data sources. By that I mean, if you're trying to track what's happening in the society or in a particular community, with regard to some infection that is spreading, you might actually look at some social media where people are looking at, oh, I'm trying to find some crocin tablets or some antibiotics. Where can I get it? So that gives you an idea that people are looking for these pharmacies. So there is some other thing going on. So maybe there is an increase of influenza or some other viral disease going on. You want to integrate some unstructured data, so text data that is available by looking at blogs, etc. Incorporating network data, and I'll give an example of that. So those are some of the ways in which you can have additional insight and innovate to create better results from what you're trying to do. Also, something that I promoted, like I mentioned earlier, is how can you get the statisticians, the operations researchers, the data mining folks, the forecasting folks, the text analytics folks, all of them share the problems that they have. And maybe one technique that is used in one discipline can be used effectively in another discipline and get better results. So that's how we keep trying to improve our software stack overall. And often, when you're trying to solve a major business solution, you need to include multiple analytical approaches to solve that. And I'll give an example of that as well. So here, I'm going to just give you a few concrete examples of where you're augmenting data to your normal data source and trying to get better results. So cancer diagnosis over the past decades have increased amazingly, and there are many types of cancer which are now almost 100% treatable if they're diagnosed early enough. So the first example is breast cancer diagnosis. There is a drug called tamoxifen, where it was found that using tamoxifen, 80% of the patients who were given that drug, they had a good positive outcome, whereas 20%, it had no effect at all. Well, 80% is a good result, so that's great. However, they dug a little bit more deeper to see, okay, who are these patients who are reacting well and who are the patients who are not? So then looking at some genetic markers in the patient data, which normally they may not have looked at, but looking at the genetic markers, they said that if there is one particular marker in their gene, that means that they 100% they can be cured with tamoxifen, and 80% of the population typically tends to have that genetic marker. So voila, so there you get it. Why is it that 80% of the people are reacting well? Because 80% of the people have the genetic marker, which automatically has an affinity for better treatment. So knowing this, of course, immediately you check their genetic makeup, and then you say, okay, this is not going to work, or it is going to work. So this is just one example of the cancer diagnosis that I'd like to mention. But there are many such, where nowadays when somebody is diagnosed with cancer, they do a genetic analysis to see if they have a tendency for better treatment, etc., etc. So that's so you're augmenting medical information of a patient data with their genetic data. So another example also in detecting melanoma, skin cancer, is use of deep learning algorithm. So we all know that we want to, when we go for any doctor's visit, we try to find the best doctor, and the best doctor is somebody who has had lots of experience, right? Or who knows about a lot of other treatments that are going on. So what does a machine learning algorithm actually do? It has the capability for looking at thousands and thousands of scans of lesions, and to say, so these lesions are all used as the training data, where they have been already identified by expert dermatologists as saying this is a cancerous lesion, this is not. So now the machine learning algorithm looks at all of them and detects what patterns they are, and that training algorithm helps the machine learning algorithm look at a new lesion or an image that is given, and then decide, okay, is this cancerous or not? So essentially, the algorithm is performing like thousands of doctors working together and sharing their data. So that's the magic of deep learning algorithm, or many of the machine learning algorithms, where it's able to do lots of analysis very quickly using lots and lots of data. So these are some of the medical insights that you can get from big data. I mentioned that augmenting your demographic data with network information is also very valuable. So here, for instance, some of the applications of in predictive modeling are when you're trying to detect fraud, or when you're trying to see who are the terrorists who are actually potentially going to harm something, or when you're trying to do targeted marketing, which is the person to whom I should market my new phone, which is the person to whom I should market my new insurance offer, etc. So naturally, if you market it to somebody who has lots and lots of friends, then you have a better chance of a roll-on effect, right? The friend buys it, the friend's friends buy it, and so on and so forth. So here is where looking at the behavior of individuals, if you augment that with the network information, who are this person's friends, how many Facebook friends does he have, how many LinkedIn connections do they have, etc. Looking at all of that, it's useful for marketing purposes. Fraud detection, likewise. So if you know that there has been some fraud committed in some insurance company or something, and you know that there is one particular agent who has been detected to be committing fraud, then look at all the other connections to that agent or to that agency, so you can detect other fraudulent cases as well. And terrorists, obviously, you can see the connection. And all of us saw this quite a bit across the world in every country. We saw that during COVID, during the pandemic, contact tracing was something that people were using quite a bit, because they wanted to know who is connected to whom, who is meeting whom, so that you could contain the spread of the virus. Why is it that when somebody had COVID in a particular neighborhood, the whole thing was shut down? Because they didn't want it to spread further. So again, network connection, right? So looking at augmenting data gives you lots of scope for innovation. The other area where I'm very passionate about is the interdisciplinary innovation that I mentioned. So the statisticians and the data mining folks who were looking at support vector machines, they had very large quadratic optimization problems that needed to be solved. And the algorithms that they were trying were not performing extremely well with large data. But then we had the OR team who was actually working on the quadratic optimization algorithm, the solver, and improving that in leaps and bounds. So getting these two teams together, the data mining team was able to use this new solver and get better results. Quantile regression is something that's used in statistics, and it is taught in statistics. It was taught many, many years ago, but it was not really used very much because we did not have access to large data. Because basically, in quantile regression, where you're trying to regress around the end deciles, the lower and the upper quantiles. So if you're looking at that, you need a lot of data. So again, that leads to large linear optimization. So these are all different examples. In deep learning, we use stochastic gradient descent methods. Reinforcement learning, that is very commonly used, the term used in data mining and machine learning, is nothing but partially observable Markov decision processes. And when we're doing credit scoring, we needed to find optimal bins for the credit rating. So again, that's a mixed integer nonlinear programming. So the teams work together to describe the problem and see what can be used. And the list can go on and on and on, and to see how we can augment by working together with all these different teams. So interdisciplinary innovation added a lot to the value of each of these different software products that we were working on. Then the other one where I mentioned that if you're trying to solve a business problem, it's not just one particular analytical technique that the company needs or the business needs. So each technology works well, but combining them is the real opportunity. So in retail, when you're looking at clearance optimization or markdown optimization or price optimization, you need to know the forecast for the demand. You need to do some statistical modeling, machine learning, and then some optimization optimization to see what prices to set. And of course, underlying all of that is the data layer. So putting all of these together to create a solution to solve it in a holistic fashion is where you get the big bang for the buck. So I like to say the whole is greater than just adding up the parts. So by adding 2 + 2 = 4, by combining together, you actually get more than 4. So again, going back to my slide of from data, you apply analytics and get value. And what has happened in the past decade or two is the data volumes have continued to grow along with the problem complexity. It has just leaps and bounds, these have grown. And so businesses are asking for performance improvement in various fashions. For instance, when you're trying to make offers to different segments of the population, or make offers for different states within the country, or decide which type of shirts or which type of dresses, which type of saris should be sold in which part of the country, all of these, you need to make analysis and build models for all these different segments separately. So if the more and more segments you create, you get into this micro segmentation, where sometimes you might have smaller and smaller groups that you want to build models for. And we did that again during COVID for the data per country, state, district. So you could have data for each little place within the country or a state to figure out what is happening there. So that's known as micro segmentation. So when you're building predictive modeling models, many of you who've built machine learning models know that you try multiple models. And for instance, you might try decision trees, you might try neural networks, you might try gradient boosting methods, all these different techniques. And for each of these techniques, there are settings, parameter settings that give you better improvement or not, right? So essentially, when you've got all these parameters for all these models that you wanted, modeling methods that you want to check for all these different subgroups, then you'd end up needing to do lots and lots of modeling. So essentially, you require automation across thousands of models, mainly because the demand for microsegmentation and automation has grown quite a bit over the years. So combining the availability of data, the computing power, and the different algorithms that are being created, it actually has been a golden era for AI, machine learning, and data science. And I think of it as a new frontier in scale, in speed, in predictive modeling, and automated data-driven decisions. Automation comes in for auto tuning, where I mentioned you need to look at multiple parameters. So if you can just set the machine to run through the different parameters and say, for this particular decision tree method, these are the settings that you should use. For this neural network, these are the levels you should use, etc., etc. So that's what I mean by auto tuning. Microsegmentation, of course, just means you want to build models across all these different segments. And often you might want to just add new variables. You might want to combine new variables and again build models with the combined variables. That in computer science is often referred to as feature engineering. So in statistics, we call it transformations, transformed variables, and use that. So like in regression, you might do logistic regression by transforming them of the variables. So when you're doing automation across a wide variety of parameters, then the intelligent search in the parameter space is what you need. So some local search optimization like genetic algorithms and so some other black box optimization methods are used in this model selection, so that you just let the machine run to select the best parameter. So you set some limits for where the search space should be, and based on that, it'll run through. So that is hyperparameter tuning. And then it also runs through multiple models that you want to try out. So these are all different opportunities for analytical innovation. I talked about exploiting computing power, automated tuning of parameters, etc. So in addition to that, that's not enough. You also need to invent some new algorithms for performance improvements and some previously intractable techniques by combining different domains. And when you have high frequency data or streaming data, you need to create some new methods. And so here is one particular example in a surveillance video. If you see in the original video, here is the video of some waiting area, like in a hospital or in an airport, wherever it might be. So the video is just monitoring people coming and going. So from that video, you want to separate the foreground and the background. So the foreground is where people are constantly moving. It's a changing scenario. Whereas the background is all the stationary items. So often you get these messages in airports or other places, right? If you see some package that is sitting there unattended, please alert somebody, because that could be someone has left some a bomb or something, some terrorist has done that. So essentially, you want to separate the foreground from the background, and you can do some of this using automated screening of the video, so that somebody is not required to look at hundreds of screens all the time and try to find this. So the technique we invented is called robust principal component analysis, and the same technique, and I've included some links in this presentation. The same technique is used for monitoring beehive health, where beehives are used. Bees are actually a great help for farm, for fertilizing and all of that, because they transport the pollen, etc. So you want to make sure that the beehives are healthy. So again, we put sensors inside the beehives so that you can detect any anomalies to check the health of the bees. So once you know, if you know that the beehive is not sounding right, then you know that the beehive is unhealthy. So you might need to do something, change the location or do something different. So again, robust principal component analysis is a new algorithm that we created to solve this problem. In manufacturing, you have, quality control is something that we are all familiar with, where previously we were looking at only a few variables to see whether the quality is deteriorating over time. Now, with the ability to capture video images as the way, so here is a manufacturing facility for a computer chip manufacturing company. So they have video images as the chip, as the assembly line, as the belt is moving. And how do you detect defects in the wafers as soon as something starts going wrong? Because even if you waste 3-4 minutes in the detection, you've already produced many chips, which are all going to have to be thrown into the dust garbage pile. So in order to be able to detect it right away, you need automatic detection of the streaming data as it's moving along. Another example of similar things, where you want to detect some issue that is happening right at the point that it's happening and take some decisions. So here, it's IoT data for positive train control. So here's an image of a locomotive that is going across the vast Midwest in America. And there are more and more regulations which say that the train locomotive should have sensors on the locomotive so that if something goes wrong, it stops right away. So again, you need to have some analytical models that are sitting right at the machine, at the locomotive, so that if something goes wrong, it stops right away. There's not enough time for the message to go back and some operator to listen to it and then make the connection. So we call this edge analytics, where you're applying analytics at the edge, where it is needed. So it could be the same thing for oil wells that are out in sea, or anything that you can think about. So the different types of analytics that I've talked about, we refer to as the analytics ecosystem, where you need to build models with data that you already have in your warehouse or in your data warehouse, etc., where we call that at-rest in analytics. When you're looking at like the manufacturing data, where there is streaming data going through, and you want to make some look at the detect the defects right away, that's known as in-motion analytics. And edge analytics is where you're monitoring equipment, like on the train or in the oil well or the platform, for failures and safety issues, and take action immediately. So these are all the different ways in which we talk about analytics deployment. So the entire life cycle is collection of data, discovering the models that make sense for that data, and then deploy it in practice. Because unless the model gets actually deployed and gets used, it's no good. It's just sitting on the shelf. So when this is in this life cycle, another important step is, of course, to keep monitoring to see, okay, is my data still the same, or has some new variables come in? Is my deployment still working? So I keep monitoring the models to see if they still are behaving well. So this continuous cycle needs to keep happening. Otherwise, you will not be able to succeed in your business project. So I've talked about the analytics. I've talked about the analytics innovation in different ways. But what are the critical barriers to success? Is it enough to have the best algorithm in the world, or is there something more? And I say that we need better data. The question is, do you have the right data? So in facial recognition, do you have all the right data to be able to recognize properly? So for instance, if you don't have the right demographic data for the population that you're going to apply the models to, then it's no good. So if you built the data using Caucasian subjects in the US and then try to apply it in India or China, it's not going to work. Likewise, if you're applying it within the US, you need to make sure that you've got all the demographic people covered. Otherwise, it's not going to work at all. So here is, I've included a TED Talk link about a researcher, Joy, who fought against bias that was being used in some of the facial recognition software that was being sent out in some of the major companies. So it's a nice TED Talk. It talks about how you need to make sure that your training data is right. Do you have the right process? So a lot of times when you're making complex decisions, like in this particular case, I've talked about the campaign management and marketing quite often, right? So this is an example where we worked on finding the right offer to make to the right customer at the right time, and through what channel. Do you call them and make an offer? Do you send them an email? What do you do? And this problem is a huge mixed integer programming problem, and it required a lot of innovative heuristics to implement. So we were very proud. We said, hey, we've got this wonderful algorithm, let's go sell it. But as we started talking to the customers, we realized that they needed to know more. How can we convince our campaign managers that this looking at the global problem is a good way, rather than giving each campaign manager their own set of campaigns that they could run on their own and not worry about what anybody else is doing? Because by doing this global optimization, it might be that one particular branch, we decide in this month there's hardly anybody that's going to come there, so let's not make any offers there. Let's focus on something else. So of course you have to convince that bank manager why we're doing this. So here is where some executive support for implementing this is needed. So the CEO or the district supervisor or somebody needs to say, okay, this is why we're doing this. This is going to make our overall profit better, and we'll find ways to share the overall profit equitably so that nobody feels left out. So what I mean is you need executive support from the upper management. Do you have acceptable results? More and more these days, interpretable machine learning models are very useful, are very required, because you want to be able to make sure that the models that are being generated and used make sense for the consumer. It could be for the data scientist. He needs to understand, why is this a good model? The end user needs to know, why did I get my loan refused, whereas my neighbor got it, and we have the exact same kind of house, we have the exact background, etc. So how do you make sure that it's a fair treatment and explain it? And policymakers at the highest level, governments, and they need to make sure that the decisions that are being made are fair and they're transparent and acceptable. So interpretable machine learning models is one of the big areas of research these days. Ethics is also very, very important. And there are lots of techniques that are being used to make sure that you ensure that the AI is ethical and does not introduce bias or exacerbate bias. And there's a very nice white paper about this that I've also included as a link here. You want to make sure that the solution is fair and has equitable income. So ethics is a big thing. There's a lot of ethics guidelines, especially in the EU, where you want to make sure that a trustworthy AI is lawful, ethical, and robust, both from a technical perspective and taking into account the social environment. So these are, again, some links that are good to look at. Then another thing that you want to think about is, as you think about automation, etc., do you need humans in the loop? And what I like to say is, you know that nowadays our airplanes fly on autopilot most of the time. But would you get on a plane if you did not see a pilot in the seat up there? Because you know that the pilot has the ability to override if the machine of if something goes wrong with the machine. You need somebody like that. And there's a lot of research going on about driverless cars. And the reason it's taking so long to make it more popular and acceptable or even approved is because there are so many issues that you need to attend to make sure that if something goes wrong with the machine, there's somebody who can override it. So it's good to think of AI as something that needs humans to get amplified results. So you need humans to recommend the strategy based on AI insights. Do you have the right people? You need analytics literacy at all levels. You need it at the leaders of the research group, the business leaders who make the investment decisions, and the ones who are creating models or using the models. And you need database engineers to make sure that the data are being stored and updated appropriately. You need students and educators who can understand potential areas of study and research. So not everybody needs to have a master's or a PhD in these subjects, but they might need to understand the business value of these techniques, etc. So Informs has a wonderful white paper again, which talks about how you can build successful OR and analytics teams. And we talk about analytics champions, analytics consumers, analytics experts, and analytics enablers. So it's a nice paper, and it will give you all these different categories who need training at different levels. So to sum it all up, in order to succeed with data and get value with automated data-driven decision-making, you need to learn to work with new sources and new types of data. You need to be able to exploit new analytical infrastructure, explore and implement new algorithms, and educate and enable and train your workforce. So with that, I'd like to say thank you all for your attention. And I hope this helped and gave you some idea. I think I'm going to stop presenting now so that I can, yeah, okay. So I hope that gave you a little bit of an idea as to what I've been working on and how I'm very passionate about it, as you can see. So yeah, and I believe there if there are any questions or is somebody monitoring the questions?
Dr. Akila will be doing the Q&A.
Okay.
Good evening, ma'am. Thank you for the wonderful session, ma'am. Few questions have been asked in the chat box. I'll take that first. Then the questions from the registration. First question from Jayashree, ma'am. With new data avenues coming up, for example, data collected by space satellite or underwater drones, etc., where the target interest group itself is unclear, how do you apply these analytics and then make a business model from this data?
So okay, thank you. I think I get the question. It's a tough one. right? And data challenges like this, as to what level can you share data, at what level can you exchange data, that's something that's constantly being discussed. In the United States, we have electronic medical records, so at least the hospitals, provided the patient gives permission, can share data across hospitals as to what's being about the patient. So that's sharing at that level. But then if you're trying to get access to what the pharma companies have used, that is very, very proprietary, right? And so I think there is a lot of work that's going on as to how can you do some deduplication or de-identification and share that. So there's a lot of research going on in figuring out how do you protect the identities of the people who are in the test pool, etc., and then share it. So there's a lot of research going on, and there are some data sets which are have been cleared like that and are available, and then you have to sign lots of NDAs to say we can use that. So it's an ongoing issue that gets tackled at different levels, and how do you share data is a big issue that needs to be addressed.
Thank you, ma'am. Next question. With different pharma companies lobbying for drugs they produce, how can AA help the public get access to objective info which are not biased by pharma corporates?
So, well, that's in a way, it comes back to similar what I said for the earlier question. Pharma companies are very protective of their data, but there is also a lot of work that's being done in an area called evidence-based research. And there are some companies, there are some nonprofit organizations, etc., which have research projects, research funding to look at globally, or not globally, sorry, what I mean is at multiple data sets, at multiple trials that have been conducted, and look at all of them to get an overall sense of what needs to be recommended, etc. For instance, when you're looking at something that I'm aware of is when you're looking at this is not necessarily pharma company, but it could be similar for pharma companies as well, is whether how much is are C-sections being used when they don't need to be. So for that kind of problem, you need to have access to patient data that have gone through all of these studies, etc., have gone through these processes, and look at all of that, right? So then there are some research that looks at all of them, or if there are some other drugs that are being tested, so looking at there is I think there's a lot of federal funding in the US that has been set aside from National Institutes of Health to do something like this. So I'm not sure whether public can get access to it, because you have to go through some process for research funding to get that. I hope that answers your question.
Yes, ma'am. Thank you. Next question from the registered participants. Can you just tell some applications of AI to train student teachers in the field of education?
Good question. So I'm not totally aware of that. I know some machine learning models have been applied in the area of accepting students, right? Whether a particular student is the right student to accept into this particular program, etc. So, or whether a particular student is the right one to whom we should give a scholarship, etc. So those types of analysis that universities have been trying to do to get a sense of what is their return on investment, right? Because they're investing in these students. So what is the return on investment? That's one area. Nowadays, you hear a lot more. My husband is a professor at UNC Chapel Hill, so I hear from him as well. Nowadays, a lot of the professors are also very aware of ChatGPT and where it could lead to some issues of did the student actually do it himself or herself, or did something else come up? Are they using a machine to do this? And those are all problems that are continuing to grow, and it's an evolving area. We need to see where it ends up.
Okay, ma'am. Ma'am, next question. What is the contribution of OR profession to deep learning methodologies?
Yes. So many of the machine learning and deep learning techniques, they very heavily rely on something known as stochastic gradient descent, and that is one of the optimization techniques that is used. That is used in these techniques. Then I mentioned that when we are looking at auto tuning or hyperparameter tuning, the local search optimization is one of the OR techniques that is being used there. Then in some of the other data mining areas, which I mentioned, the credit score optimization, credit optimization, you're looking at optimized binning. How do you find the right bin so that you can say if a patient's characteristics fall within this bin, then you accept or otherwise reject, and so on. So and there are lots of constraints that need to be put in place so that it's a monotonic function, so that it doesn't approve and then suddenly the next bin says don't approve type of thing. So those are all constraints that can be handled by OR types of formulation and not otherwise. So those are some of the ways in which we are using. Then reinforcement learning is just Markov decision processes, and those are the techniques that are being used there as well. So there are many places where some of the lower level routines that are used in OR solvers get used in machine learning and deep learning methods.
Next question, ma'am. How ChatGPT is generating answers?
So there is an interesting article that I can send to you all, and you can post it, which I had a very good analysis of how ChatGPT works. So ChatGPT is a little different from Google search. So when you're doing, or any of the search engines, when you're doing any of the search engines, it's looking for specific phrases or specific combinations of words, and looking at a wide set of data and picking the articles that are most relevant to that. Whereas ChatGPT, what makes it look almost so magical is that it's looking at all the text data and in different ways and using some large language models. I don't know the details of how it works, but large language models is the technique that people refer to that, where it's using that to combine information from these different sources and then creates a narrative around based on items or little bits of information that it's picked up from all of these. So a problem with something like that is that if the sources that ChatGPT looks at has false information, that false information gets is included, and it comes up with the wrong answer. And now if you keep asking questions and it keeps adding more and more false information, so the body of data that it's looking at has more false information, so it could get more and more down a rabbit hole and get worse and worse results. So there are some techniques that people are trying to build so that it avoids that. And so you will notice that if you ask ChatGPT some question, it comes back, and then you say, well, wait a minute, that's not quite. Then it'll apologize. It says, oh, I'm sorry, ma'am. Here, let me try again. And it'll come back with something else. So now it knows that, okay, what I said before is wrong. So then it tries to correct it. So it keeps doing that. So it's an interesting way in which it's building the data and using information from there. So I can send the link to the article that I think that does a really nice analysis of what it is and what it isn't, ChatGPT.
Thank you so much, ma'am. Next question. how we can feed hybrid algorithm implementation in a tool?
It requires a lot of collaboration between the teams. So you need to be able to, creating an algorithm that you are yourself are going to use and people like you are going to use is one thing. But now, if you want your algorithm to be used by a wide range of people who may not know all the different nuances of your field, then you have to make the user interface in such a way that it can hook up to whatever infrastructure you have. So you need to know what infrastructure you're building it for and how do you interact with it. So when you're building a solution for solving a complex business problem, this is where it is very, very important to work with the business domain experts who are going to use it. How are the end users going to use it? You understand that. And then you build a wrapper. Sometimes you might have a complex algorithm, but then you build a wrapper around it that makes it easy for the consumer. So when we built our solvers that had to be put into a statistical routine or a data mining routine, we needed to make sure that the connections, the hooks, fit in properly, that it can then be put together. So it requires a lot of collaboration among your consumers, and you need to have user acceptance. So we build something, you try it out, and then you say, oh gosh, that's not how I intended it to be used. Then you try to fix it. You try to put a safeguard and guardrails. And quite often when you're working with people who don't understand how you came up with it, you need to put guardrails in place so that your algorithm doesn't go off the rails and it still remains appropriately used.
Yes, ma'am. Thank you. One more question. How to improve accuracy and challenges faced in the machine learning model?
By continuously monitoring it and by making sure that you have the right data and testing. You have to continuously test. So you need to have a holdout sample and your training data, and then you look at the holdout data and make sure that the holdout data is being, when I say holdout data, that this data, what the results should be, and you're using the training data to create your model. Then you apply it to your holdout sample to see if it's behaving correctly and look at different metrics. So any good tool, and there are lots of automated tools nowadays to build machine learning models, and any good tool will have these in terms of graphs and charts and tables which look at the area under the curve, ROC, lots and lots of these metrics to look at it to say, is it behaving properly? For forecasting models, what is the MAPE, what is the forecasting error, and all of these things you look at and then decide. So you need to have all of these metrics that you decide beforehand as you're going to use this to make sure that your models are correct, and then keep monitoring it. Continue to do that as more and more data come in. Make sure that your models continue to behave well and haven't deteriorated over time.
Thank you, ma'am. Next question. How to apply ML and its optimization techniques to real-world applications on problems?
Yeah, thank you. So I would say that some of the examples that I talked about, and some of my team members worked on real problems, and they were applying the machine learning and optimization techniques to those problems. The key is, first and foremost, don't start by saying, okay, I'm going to use decision trees, neural networks, I'm going to use mixed integer program, etc. That's not where you start. You start with the problem definition. You need to understand that what the problem is and what is it that they want to achieve. So get that understood well across the team. Make sure your researchers understand that as well. And you continuously work with the whole team to say, okay, this is what we are trying to do, and start small, right? And always have an idea of how it currently is functioning, how this problem is being solved today. So the term often used in consulting engagements is what is business as usual. So always comparing what you're doing with business as usual, BAU, is something that is very important. So you need to have a clear definition of what is success. You need to have a clear idea as to what is currently being used, and start looking at incremental improvement so that you build trust. So no matter how complicated your problem is, or your algorithm is, you don't want to, dazzle them with your brilliance and say, I'm using this complicated algorithm. For them, it doesn't matter. They don't care two hoots about it. What they really care is, has it made a difference? So you want to show that what you're doing is actually making a difference. So comparison to business as usual is important. And then being able to explain to the stakeholders. So make sure that your stakeholders are involved in all these decisions right from the beginning. So they need to know that you are listening to them and you are addressing all their concerns. So those are, and simulation is something that I should mention is very, very important. So when you put in a solution at a place where behind the scenes, there's all these complicated optimization, machine learning models, etc. But then you provide some simulations in the tool that you hand over to the customer, where they're able to say, okay, here are some possible scenarios, what happens in this case? So the ability to simulate is very, very important as well.
Thank you, ma'am. One last question. With considerable data being pooled globally, how can cross-border data privacy issues handled by each country?
Oh boy, that's a difficult one. And I think, it is something that I'm not too familiar with how they've been doing it. I think for some things, people, I think in the EU, because they work as one unit, they have lots of things set up so that they handle data privacy. And the European Union has very strict regulations with regard to GDPR, global data privacy rules that they have to follow. So you have to make sure that you have those. So before you share any data at all, you need to make sure that there is very strict guidance and very strict adherence to the GDPR rules before you can share that. So we need to continue to expand things like that. And I think the GDPR is one set of rules that have been put in place. And, one of the questions I had is how much of the electronic health records, even within the country, can be shared, right? There are some there was a major rehaul in all the health systems in the US, where all the hospitals started following one particular way of recording data and patient data and all the information about their treatment, etc. But of course, you need the signature and the approval and the acceptance of the patient to be able to share it. So even if I go to this hospital and then I go to another hospital, you need to sign that, okay, this hospital can share this. But once you've signed that, that hospital has full access to look at your medical data. But that required a whole infrastructure to be set in place. So what is it? First, of course, there's no place, you have to begin at home, right? So the question is, how much of this is being done today within the Indian hospitals? And I spoke to one of the chief statisticians in India just last night to ask about this. And that's a work in progress. It's something that needs to be worked on as to how do you share data across multiple, you need to have similar metrics, similar ways of counting everything. So it is a huge challenge and something that, we need to keep working on. And privacy is paramount. It's very, very important to make sure. And then, of course, there's all these issues we have with computer hacks and stuff like that. So, some things could go wrong. But so it's a work in progress.
Thank you. Thank you for your enhancement. Any participants, if you have questions, you can unmute and just ask the speaker.
Yeah, I have a question. It's about the reliability of the models based on the synthetic data. Nowadays, people are working on synthetic data. So what could be the Are there any reliability issues with synthetic data? Or will it introduce any bias? Basically, synthetic data is based on certain assumptions, right? So,
Yes.
so what are the issues related to synthetic data in machine learning models?
Yeah, no, good question. And I think you yourself have included part of the answer that there needs to be a careful study, and research is ongoing again on figuring out how best to create synthetic data based on the existing data that you have. How can you augment it? How can you increase? And in some of the especially in health records and stuff like that, when you already have some information, can you generate more data that follow the distribution network, or whatever, sorry, the probability distribution of the data that is there, and create more that you can then feed to your machine learning algorithms. But again, it's you need to come back and make sure that you're not creating undue bias. So looking at the bias in algorithms is something that continues to be an ongoing area of research in many of the machine learning teams.
And did you mean by simulation the digital twins?
Digital twin, I didn't quite mean digital twin in this instance, but yes, a digital twin is something that is being used very much now, especially in manufacturing. Because you cannot, you cannot really, use your models directly in where it's going to be applied, sometimes without actually damaging the system itself, right? So creating a digital twin which mimics the behavior of the system that you're trying to influence, that you're trying to build your models for, is something that is very commonly used even for supply chains. In supply chains, when you've got a chain which goes through multiple different providers, multiple different distribution companies, transportation, etc., you create a digital twin which simulates, or which mimics that system, the entire system that you're trying to solve for, and then apply your models on that to see how it behaves. So digital twins, I'm glad you mentioned that, because digital twins is an area that a lot of work is being done. And even last week when I was attending the Informs conference, there was a very nice talk about using digital twins for an inventory optimization problem.
Yeah, good evening. I have a question. Yeah, I for the wonderful talk. Nice. Really, I just forgot an hour has been passed. So wonderful talk. Yeah, it really is good. Yeah, I have one question. Yeah, I am supposed to be your junior in Presidency College.
Oh,
Just
okay.
now, I did my postgraduate there. Yeah, so just after our introduction, I came to know that presidency. Yeah. So, how important is the researcher? They should know the importance of probability distribution, support vector machine, regression analysis, because almost all softwares are available for their use. How much important is to know the basics of these distributions and other things?
Good question. And, the link that I posted about the different types of analytics users that are important in an organization gives a very good description of that. So it depends. If you are actually building new algorithms, then of course, goes without saying, you need to understand the details of all the whys and the wherefores and everything. If you're using them, like you said, the software tools nowadays have a lot of it where it's just point and click, right? And I want to try all these models, support vector machine, decision tree, neural networks, boom, run it and come back, right? So there, for the person who's using it, it's not that important that he understands the nitty-gritty details of how the support vector machine was built and what it is doing or whatever. But he needs to understand and interpret the results it is providing, and know enough about it to understand, is it making sense even? right?
Okay.
So he needs to understand what it's providing and then based on it, because he doesn't need to know what particular complicated algorithm or method was used underneath it. But unless, of course, he wants to build a new one similar to that, right? So again, those the people who are using it, I would say, is an analytics consumer, whereas the person who's building it is an analytics expert.
Okay. Okay. Thank you. Thank you.
Okay. And again, even at the analytics expert, I would say the levels vary, right? If there's somebody who's building the back end algorithm, he needs to be deeper, probably have a PhD or advanced degree in that area. But if there is somebody who's building the user interface for it, he needs to probably understand a little bit more and work closer with the researcher to understand how to place it so that the analytics end user, the consumer, can totally understand the result that's coming out. So nowadays, a lot of software tools, in addition to providing these bars and these graphs and everything, it gives a description of what the result is actually telling you. What does it mean?
Yeah, because as you said in your talk, during your talk, people will be doing wonderful simulations in their research papers. Yeah, of course, if they do some analytics, real analytics, if knowing by distribution, it should be really a good paper. While reading these papers, I have these kind of doubts. So that's why I raised. Thank you. Yeah. Thanks. Yeah.
Any more questions from the participants?
We can wind up. Formal
Okay.
vote of.
I request our chair, Mythili Prakash ma'am, to propose the vote of thanks.
Thank you, Akila. Thank you so much.
Yes, as he told already, as we don't know how the time passes very fast. It's almost 1.5 hours it's going to be, but quite very interesting. You have given very elaborate details. Start with what is OR
And about big data, how it's used in the medical field, and the exploitation of the network, business need and performance, and so on. So much, with not bad search optimization, analytical life model too, which is very much easy to understand in such a way about ethics and AI. I've really very good details, got more information even for a raw person like me also. I could able to understand a lot about this topic. And I have to thank to the audience raised so many questions through which we can extend and acquiring more knowledge. Very good answers and elaborate answers for each and every question. I really appreciate your patience and really about the in-depth knowledge in the subject. We are really lucky to have you in this session. Thank you so much for your valuable early morning time sharing with us. That is a special I have to mention. In the early morning, you have spent your time, wake up and get ready for so much. Thanks a lot, madam. And I have to thank Mr. H.R. Mohan for bringing such a novel person. Very excellent session for us every time. And also, I have to thank IEEE, ACM, and ORSI for joining society, always being with us to make it. Last but least, the participants, without whom the session won't be interesting and successful. Thank you so much, everyone. And we wish all of you should join in all our upcoming sessions also. You will always receive, once you have registered with us for any of the webinars, we will send you that information about the upcoming seminars also. Please do join and encourage us. Thanks a lot, everyone. Thank you so much.
Thank you so much to the organizers and Mr. Mohan especially for inviting me. So thanks to IEEE, CSI, ORSI, and ACM for giving me this wonderful opportunity to talk to all of you. As you can tell, I'm excited, and thank you very, very much.
Thank you very much, madam. And in fact,
Yeah, and
we may be disturbing you with a few more calls, few more, emails, because we want your knowledge to be shared with a lot more people. And in fact, people are starving for good webinars and lectures, particularly with the in-depth knowledge like yours. So we want to reach more and more people. So we do get a lot of requests from various institutions, and IEEE has got a policy of working with closely with some of the experts, in various areas, and try to. We have our own database. We maintain our own
okay.
database of. We call them as expert speakers, and we try to sort of, with the consent of the speakers, we share the information with the people, who are wanting to organize some programs. Definitely, we would like to take your consent and then uh, let them know in advance, and definitely they will get in touch with you well in advance and fix up some time. And all this thing, it won't be a very short notice, definitely. So this
Thank
will
you
be
so
a,
much.
yeah, it may look like a starting of trouble, but anyhow, that will be.
And thank you so much. And, I love sharing my experience, so it's not a problem. Thank you. And good
I
night.
could
It's not too early for me. It was 8:30 here. That's not too early. I think it's more late for you guys. So thank you. Thanks so
Thank
much.
you.
And hope to see
Have a
some.
great day, madam. Have a
Yeah,
great day.
thank you. Thank you. Yeah. Bye-bye. Bye-bye.
Thank you, Dr. Nambi. So good.
Thank you, sir. Thank you.
So
Yeah, thank you.
we'll follow many
Yeah.
things,
Thank you.
Thank you, sir.
Okay.
Thank you.
Paklam. We'll see tomorrow, right?
Baklam, sir. Tomorrow, yeah.